Welcome to our expert talk, which is all about sustainability. Licek machines are known for the excellent quality, but are they sustainable? We will find out. Let me first introduce our technical experts. Let's start with Mr. Markus Lieninger. He's from the engineering department. Then next to him is Mr. Christoph Stöffelbauer. He's our product manager for glass cutting and logistics. Then we have Mr. Markus Jandl, our director for product management. We have Mr. Christoph Luega, he's product manager for glass processing, and Mr. Jürgen Gartlehner, who is our product manager for software. Mr. Lieninger, first question is for you. How do sustainability and Licek match up?
Yeah, first, Licek machines are built with a very high range vertically in manufacturing. We have many suppliers directly from Austria and the surrounding countries. This avoids long transport routes and ensures also a stable supply chain.
You work in the insulating glass area at Licek. What is Licek's sustainable approach here?
Yeah, there are many ways we go. First, I would like to mention the material consumption at the TPA applicator. There we can, via a special nozzle design, meet the requirements of the production of our customers. For example, let's say you have a spacer with a width maximum 12 millimeters, then you can also reduce a little bit the thickness of the spacer, and this results in a minimum possible consumption rate of material, of TPA material. Another point I would like to mention is the electrical heating in all our machines with dosing systems. Normally you have material which has to be heated up first, that it is able to flow, and we can applicate it on the glass and so on. Besides that, every part is best possible with thermal insulating. We have also a management system for preheating and also reduction of the heating temperature if it's not in operated mode, and this all results in a low energy consumption. Another point is the washing machines. There we have an optimum compromise between washing quality and water consumption. This is done with several washing zones in a row, and also with a sophisticated filter system with an automatic backwash. Next, maybe a general point, the technology in electrical drives is always advancing in direction to be more energy efficient, and also our new developments at our machines, we use always the newest technology in electric drives, and this ends up also in a very good energy saving potential for our customers. And maybe one last point, a very important machine in the IG line is also the sealing robot, and there you have an important component of materials, the 2K sealing. The mixing sections inside such a robot with a very low dead volume, and we have an automatic purging mode, and this ends up in a very good outcome of material, of one material drum, and minimizes also the waste, and this is good for saving costs and saving our environment.
Well, that's very impressive. There is indeed a very sustainable approach. Mr. Stöffelbauer, how do you define sustainability in the area of glass cutting?
Yes, first of all, on the one hand, our modular construction and the uniformity of the parts which one we use is dramatically decreasing the material consumption, and this is, in our opinion, a very important point to ensure sustainability, to use the same parts and to reduce material consumption. And this has additionally the benefit for our customers also to keep less spare parts on stock. This is also decreasing the space which one is needed in the stock, and this is also, in our opinion, a very efficient way and a point of sustainability. Yes, and on the other hand, the cutting technology itself is very important for a sustainable future, because the new cutting technology, where we use the process know-how which one collected the several years, we are using to improve the cutting result, and when the cutting result is improved, the edge quality is getting better, the edge quality is getting much more accurate, and this is decreasing, for example, the grinding addition. And when we decrease the grinding addition for the further processes, we reduce cutting and grinding tools, etc. And this is also saving resources. Additionally, cutting quality has also a huge impact on glass breakage, and if we improve the edge quality, the breakage rate is getting decreased, so the glass usage is also getting decreased, and our customers save a lot of glass, and this is also very important for the future, especially because in the industrial nations in the western parts of the world, huge enterprises have to pay off special carbon emission taxes. We see this kind of trend, and when we decrease the glass which one is getting used, the companies in the future also do not have to pay that amount of carbon emission taxes. And so when we save glass, so we go ahead in a sustainable way.
Wow, I mean the Leipzig cutting machines are already set for a sustainable future. Let's dig a little bit deeper. You are also responsible for logistics. Sustainability and logistics, is that the perfect match? How do solutions in glass logistics contribute to sustainability?
Yes, logistics, in our opinion, is the basis for going ahead into a much more efficient future, because stationary and the mobile sorting systems allow our customers to optimize their production in bigger batches. This allow that the cutting results can be optimized much more efficient, so we decrease with a better optimization result the glass waste. Mm-hmm. This is on the one hand the connection to sustainability, and additionally sorting systems which one are connected with the machines decrease the amount of operator needs. So the operators do not have anymore to touch every piece of glass, so we decrease the handling need of the operators, so we decrease glass breakages, so we improve the quality. This has a huge impact also on glass consumption, and also in terms of safety. This is a very important topic. So we see that glass logistics is getting one of the most important points for the future. Yeah.
Thanks very much for those insights. Let's come to lamination. Mr. Jandl, is the lamination process very energy intensive?
It can be. if the wrong heating technology is used for a specific laminate product, it can be a problem, yes. For a homogeneous and fast heating of the lamination flow, LISIC is used the infrared heating for clear glass and the high convection heating for Louis coated or painted glass. According to the laminate structure, one or the other heating source is used with a higher proportion. And this combination allows us one of the fastest lamination speeds on the market with a very compact furnace length. Also, the eco heaters is a good opportunity to save energy, especially during the lamination of small laminate products. That means we can switch with the eco heaters the infrared lamps from the total furnace width to the half furnace width to save energy and also to avoid an overheating of the furnace. But also a small footprint of the climatic room and the higher automation level of the total line with less operators in the assembling area saves energy.
Well, also a very sustainable approach here. Let's come to glass processing. Mr. Loeger, you are responsible for the glass processing area. What resources are used here and how is sustainability ensured in the process?
For the glass processing itself, the typical resources used from our customers are water, the energy, also power, and also compressed air, which is also very expensive. And for sure, our approach on every new developing project is to reduce these resources as much as possible for the customers. So what we do since many years is that we use the water, the process water, go into loop, recycle the water and use it again for the processing machine. So that's pretty common for us and almost all of our machines using this technology. But also for the compressed air, for example, we have a perfect sealing on the y-axis, so the wet area is very small. All the electronic components are in the dry area, not in the wet area anymore. So we do not need this high amount of sealing air for all of these components. And also for the power, we always use machining concepts with 1 to maximum of 4 spindles. If you compare this to other concepts where they use 40, 50 spindles in the machines, we only have to run 4 spindles. So we only need the power for these 4 spindles. So for sure they need much less energy than the other concepts. Yeah.
What influence does productivity have on the consumption of resources? What would you say?
That's a good question, because from the first side it may seem that a machine which produces a lot of glasses may also have a higher need for resources, but it's important or interesting to have a look on the resources per hour, but much more interesting is the resources per finished glass sheet, because that's what you have to count at the end of the day. And if you have a line like, for example, KSR, most of our customers will know this machine, you need a certain amount of water for the cooling per hour, but it makes a huge difference if you can produce 50 or 100 glass pieces in this hour. So all of our LISIC machines have a really outstanding productivity, so the resources are cut in half in most of the machines compared to other concepts because of this high productivity. Yep.
Does the quality of the produced sheets of glass also have an influence on the consumption of resources?
Yeah, absolutely. We heard it before from Mr. Stöffelbauer on the logistics question. We had talked about reducing the operator influence, so avoiding scratches and so on. That's the same thing on processing. For example, the seaming line, the KSR, the only thing it has to do is to smooth the edge of the glass that it will not break during tempering. So just imagine if the quality isn't good enough and every 10th glass will break inside the furnace, you have to reproduce this glass from the very beginning. So you have to create this glass, you produce it, you have to cut it, you have to put it through the tempering, to the seaming line and also through the tempering furnace. So you have double the amount of resources needed for this one glass sheet if you have a remake. So that's very important. So the influence of the quality and stability is very high on the need of resources, and as our customers will know, the quality on LISIC machines is pretty good, so we have a very low rate of remakes, so this also saves a lot of resources, also in processing. Yeah.
So last but not least, we come to Mr. Jürgen Gatlehner. So far we have only talked about sustainability in relation to our machines. What about the software area, Mr. Gatlehner? Can you give us a few examples of criteria for sustainable software?
One of the biggest points is modularity. As you may know, software consists of many modules often, and software itself should be designed in a way that it uses resources of only the specific module that needs to be that needs to have those resources at this point in time, instead of using multiple resources from multiple modules. Another factor then is that these resources, of course, should be as low as possible and as efficient as possible in terms of data storage, network usage, and those kind of things. And the third factor could be the standard, to use standards like standard interfaces. Because really a software should only have the title to be sustainable if it used standards, otherwise you would have a kind of a monopoly position.
My last question, on a final note, Mr. Gatlehner. What is green IT and what does it stand for at Leisig?
Yeah, most people, when they hear green IT, they think of resource-effective hardware or low energy hardware and that kind of things. However, software is just as important as the hardware because it drives basically the usage and the resources of this hardware. So with Leisig, or in Leisig, we mean with sustainable software to have as less impact as possible throughout the whole environment of the software and also throughout the whole life cycle of the software itself. And with environment here again, I mean the hardware usage, the network usage, data storage, and so on and so forth. And really it starts already at the life cycle of the development. So in the development already we use tools and agile methods to develop software. And also in addition to that, we are more and more moving to the cloud, meaning that we don't have any on-site installation. We save hardware there. And also the deployment is of the software and software updates are more sustainable, in total.
So, gentlemen, thank you for your time and thank you for answering my question. I believe at that point we can answer our initial question if Leisig products are sustainable, and I would go so far as to say yes, they are sustainable. So also to our online guests, thanks for watching our session today.